This is Mark Buckhalter, a member of the Community Association Resource Group, affectionately known as CARG, C-A-R-G. Today, first of all, I'd like to really welcome everybody and thank you for participating. We have a specialist in paving today. One of our members is DMI Paving and Sealcoating. Chad, who is the resident engineer, will be going ahead and giving an informative talk, and we'll be taking questions from you. You can go ahead and either write in your questions, or if you would like to go ahead and speak, we can, Jeff, just butt in, but we can probably enable your mic to go ahead and speak. Very quickly, COG, or Community Association Resource Group, is really just a consortium of individuals, individual companies, all related to associations. So that's one of their specialties. Obviously, they'll do parking lots, let's say on DMI, they'll do that in shopping centers, but you know, they do specialize in homeowner associations. Some of the members is Popular Bank, which is for banking. We have a cable consultant, community cable consultants. We have right now online with us, we have Andrew from Maori Elevator, who's been, really a long time elevator company in South Florida, very well known. And more importantly, the customer service that Andrew and his company provides is really just outstanding. We have a new member that's a gate and access control company, Diamond Gate. Also, that someone who signed in is Tyler from Valley Insurance. Obviously, that's usually like a dirty word these days in associations, just because how the insurance has really skyrocketed over the last few years. But Tyler does have some good contacts and probably some good information on how some of the rates are starting to come down. We have janitorial and light maintenance, that's professional builders. Also with us today online is Charles from GRC Landscaping. Jeff, who is our marketing guru from Support Depot, is on. Obviously, DMI Paving, who's hosting this webinar. We also have a pest control company called Forever Gone Pest. We have a pool service, Hickson Pool. And then we also have Pallets Roofing, especially getting into the hurricane season. It's always good to check out your roof beforehand, before it starts coming down and your units are getting flooded out. And then there's myself. I'm Mark Buckhalter with AccountSalt. We do monthly accounting. We don't do any auditing. We strictly do the monthly accounting. Especially now with budget season, we sit down with all the clients and we prepare a good budget for 2026. I always do carry an extra bag of tissues, and just in case all the cries start coming out once they see the bottom line number and the maintenance has gone up. But between Valium and the tissues, we get you through it. Even those people that have joined us right now, if you're not one of my clients, you can always reach out to me just for a question. There's no cost or obligation. And that's the same really with all of our members. So if you ever have a question on any project, you can go to COG for help. That's CARG, the number 4 help, HELP.org. You can go ahead and see our contacts. You can give us a call direct, or you can leave a message, a written message on the website. With all of that said, I want to turn it over to Chad, the engineer for DMI Paving. And Chad, just go over pretty much as far as when you want questions, because we'll have write-ins, and if I see them, I can interrupt you, or you can monitor it yourself. That's really up to you.
Yeah, thank you, Mark, and I appreciate everyone for calling in today. I know everyone has a busy schedule, and I hope to keep this as informative for you as possible. Yeah, I like to work the questions out of the chat and then touch them all at the end, and that gives people a chance to ask follow-up questions once I go through the chat, and we can probably just keep it best that way. Live, I like to do a little bit of interactive, but these are certainly different. Kind of brings me back to COVID days. But yeah, I think that everyone's kind of set up to learn something. We'll share the slides afterwards, and yeah, hopefully walk away with a couple new tricks of the trade or understandings of a little bit more about asphalt pavement. So with that, I'll probably just get started. Go ahead and share my
Sounds
screen.
good. Just as Chad is sharing his screen, I just want to mention to everybody that the chat area is for technical questions only. For me, if you have any issues with Zoom or you want to know how to do something, if you have any questions for the course material for Chad or for any of our card partners today, please use the Q&A module, not the chat module, but the Q&A module. It's much easier to keep track of, and we won't let it slip by. So the chat module only for technical questions, and that's also later where we're going to put the evaluation link for today's class, which Chad needs to collect information to report your CEU credits if you are a manager. With that said, back to you guys. Thank you.
Thank you very much, Jeff. All right, we're going to get started. So today we're learning about asphalt pavement, hot mix asphalt characteristics and maintenance techniques. I am Chad Mackey. I'm our Chief Engineer and Operations Manager of DMI Paving and Sealcoating. I've been in the game here for about 14 years in South Florida. I'm a civil engineer by trade. A little bit about me. That my degree is from the University of Arkansas. Yes, that is an accredited institution, equivalent to a degree from Georgia Tech for a little bit more economic means. I was a civil engineering consultant for the first 6 years of my professional career. I was actually wanted to be a water resources, water quality engineer. So that was the first part of it, but I did a lot of design work, a lot of consulting work, and kind of moved my way into transportation materials and logistics. I was a facilities manager after I left the engineering world for the world's largest retailer, who shall remain nameless, but you'll probably pass one on the way home. And I managed their network of stores and distribution centers across the country with regard to all of their parking lots and concrete sidewalk signage, etc. So I've been on the buyer side before and dealt with gnarly contractors nationwide. When that wasn't crazy enough, I picked up my family and moved them to Chicago for a brief stint as a national paving manager, and kind of started doing the contractor side. And after dealing with 2 horrendous winters and a bout of seasonal depression, I called my friend Ray, who is now retired here in Miami, and I said, hey, let's make a deal. And the rest is kind of history. So we are DMI Paving and Sealcoating. We are a Florida-based company. We do pretty much everything, asphalt, concrete, maintenance, construction, and ADA work. We do everything from capital project overlays to ADA upgrades, concrete sidewalk rebuilds, and down to striping, signage, and just general maintenance. So today we're going to be dealing with the asphalt side of things. Like I said, if you have questions, and I hope you do, go ahead and throw them in the chat, and then we will address them at the end of the show. All right, today we've got some objectives here. Primarily, we're going to talk about what are the components of an asphalt surface course. Asphalt isn't a material that you can just go and purchase off the street. Okay, you can't go into a hardware store and say, I need 2 tons of asphalt. Okay, this is a conglomerate material, and it's made in a plant under very specific controls and guidelines. We're going to walk through how this asphalt is produced, what all goes into it. Then we're going to walk through a general procedure of all that we do to lay down new asphalt pavement. After we get done with seeing how we construct it, we're going to talk about all of the things that affect it and all of the things that erode it. Realize the most erosive substance that affects it and everything else that can damage it. We'll talk about what type of failures asphalt kind of goes through during its useful life. And then we'll talk about what repair types correspond with each type of failure. And then we'll spend a brief moment on the methods and reasons for proactive or preventative maintenance. So we're not constantly going in and patching potholes and doing kind of reactive work, and we're planning kind of for the future so we can budget better and so we don't have liabilities or libelous conditions on our property. This is a typical asphalt pavement cross-section. A cross-section is basically if I ran a saw blade down the center of an asphalt pavement or down the center of a wood table, this is what you would see if you looked directly at that saw cut. Okay, so asphalt is a conglomerate material, like I said, but asphalt isn't something that you can just go get from the plant, dig out 2 or 3 inches of native soil, compact it, and then put the asphalt down. If you did that, your asphalt would fail immediately on putting a load on it. Okay, so part of the structural number, about 25% of the strength and 100% of the foundation of an asphalt pavement is called the base course. And what that's made of, particularly here in South Florida, is a lime rock base. Okay, this is our foundation, and it's going to act as a bridge between the native soil material and the traffic loading portion, which is going to be our surface course. It's typically between 6 to 8 inches thick, and it is constructed so that we have a solid neutral force or a neutral foundation below that asphalt, so that when a load is applied to it, it's distributed down through the surface of the asphalt, through the base, and then it acts as the neutral force back up to counterbalance that load that we put on asphalt. On top of that base, we've got our asphalt surface course. Now, in other parts of the world, or certainly other parts of America that aren't South Florida or most of Florida, this surface course can be anywhere from 3 to 4 inches thick. And sometimes they'll even have 2 layers of asphalt. They'll have what we call a base or binder course, which is a little bit larger rock for loading. And then a second course that's going to be your surface course or wearing course. That's what you actually drive on. That's going to be the smoothest, smallest rock course. Down here, we're very fortunate to have free draining soils. We don't have freeze thaw scenarios. So we're able to get by with a lot of times one layer and a very thin layer. You know, our asphalt can be as thin as 1 inch down here, which is unheard of when you come from where I come from. In Arkansas, our typical pavement section was 4 inches of asphalt on 6 inches of base. In Chicago, we could get up to 7 or 8 inches, depending on the use of asphalt, and then the base. So you can see how much excavation it takes to do new construction of asphalt in parts of the country that get freeze thaw cycles versus South Florida, who has a very nice climate and very free draining soils, okay, with limited exceptions. All right, so we're dealing, typically if I'm building a new asphalt pavement, I'm going to put 1.5 inches of asphalt over 6 inches of base course and call it good. What you see on the other portion of this cross section is sometimes you have a selected granular material. That means I want a material underneath my base course that's going to drain any groundwater, or it's going to drain any surface water that's collected there down to the subgrade. Okay, and your subgrade is just going to be your native in situ soil, or basically what God gave you to work with from the beginning. What are the components of an asphalt surface course? Okay, 95% of asphalt concrete is just aggregate rock, but it's not gravel. Okay, don't kind of get that idea out of your head that this aggregate rock is just a gravel or 57 stone that's all the same size. It is about anywhere from 8 to 12 different sizes and types of rock. Okay, we need it to have large rock, and that's going to be kind of our load bearing rock and stone. And then we need it to have small aggregates, sand, fines, even down to dust that are void filling. We also need these to be angular. Okay, we don't want rounded edges or smooth stone in our asphalt, because it's impossible to get that tight compactness and not create voids. When you have voids that are present in the asphalt rock mixture, the rocks don't bind together when they're compacted, and you have open space. When you have open space and you put a load on it, what happens? You get deflection of the pavement. Okay, so we want all this large rock, small rock, fines, and dust to all kind of come together to create pretty much a solid matrix with very, very minute voids in between them. The next 5% is simply our asphalt concrete or liquid binder. That's what's going to hold everything together. Okay, this is also what drives the cost of asphalt and the price. So this is asphalt binder. It's the resultant of the refining process of petroleum, and we're going to put anywhere from 4% to 7% of the total volume of this material as hot liquid binder. That's what makes the pavement black, and that's what holds all the rock together. Without the rock, binder is useless. without the binder, the rock is just a gravel road. Okay, so this is where we're going to mix it in the plant together. You mix it all together at a very high temperature and you get bituminous asphaltic concrete, which we just refer to as asphalt. You can see how people would start confusing asphaltic concrete with regular Portland cement concrete very quickly. They allowed us engineers to go back and say, okay, how can we confuse the public less when we're talking about our pavement materials? And in this case, we're just going to call it asphalt. How do we produce this stuff? All right, so we're going to determine our design based on the intended use. I'm not going to use the same asphalt pavement on an HOA community street as I would in a Publix loading dock area or as I would on an interstate. Okay, so I'm really determining how much load is going to be on it when we design an asphalt pavement, especially the thickness, but also the type. We're looking at how many trucks are going to be over that pavement, driven on that pavement in any given time frame. We don't design asphalt thickness or mixes based on how many cars are going to be on it. They're inconsequential to the strength and longevity of asphalt pavement. We design it based on truckloads and drainage characteristics predominantly. What are we putting on it? What's the intended use of that pavement? Is it a neighborhood street? Is it an interstate? Is it a distribution center? Is it a shopping center? All of those may have a different specified material. Okay. The amount of each component is based on the design. So how much of each size of rock finds an asphalt binder? There's about 25 plus or minus FDOT approved asphalt mixes that run the gamut of different consistencies, different rock sizes, different binder contents, different percentages of a recycled pavement, etc. Okay, so about 9 of those are surface mixes, or what you would put on the top for us to drive and walk on. All these components are mixed at the plant and heated at temps between 275 and 325. This stuff has got to be super, super hot. And we heat the rock ahead of time in a kiln, okay? So we're not just adding hot binder to cold rock. Your binder would cool immediately and you wouldn't get the material consistency that you're looking for. We need this stuff to essentially be liquid when it's coming out of the plant silo into the back of our trucks, and when it's being placed from the trucks out onto the job site from the paver. You need it to be malleable. It's got to be workable. Otherwise, you won't ever get compaction and you won't be able to loot rake it. You won't be able to shovel it. You won't be able to do anything. So it's very important that we keep it at a very high temperature while we're putting it down and working it and compacting it, and then we can allow it to cool. Okay, so once it cools, it hardens up and it kind of becomes the solid material that we know that we drive on every day. But while it's going down, we got to keep it super, super hot. The finished mixture is then placed in silos for trucks to be loaded and the material to be hauled to the job site. So you can see before DMI even touches asphalt material, there's a lot of things that are in play. First, the design has to be completed at the plant level and at the federal level. Then they actually have to make the material. Then it gets stored in the silos. Then we can come pick it up and bring it to the job site. This is an example of a really nice hot mix asphalt plant. This plant has 3, you can see the silos there, and behind it, you can see all of the bins of different aggregate rock that are used to produce it. Okay, so all the conveyors and everything you see there is all part of this. Once it goes through the kiln and we dial in all of our percentages of rock and the right amount of binder, it mixes together and then they place it in those silos. Those silos can hold about 460 tons each. And so this plant can run 3 different asphalt mixes at one time and be ready to deliver on those. In the back, you can see the stockpiles of the rock. I wasn't joking when I said there were different rock, different sizes, different gradations, different types of rock, all from the quarry. The only difference is the black pile that's in the top right corner isn't aggregate rock at all. That's called recycled asphalt pavement, and it's used to kind of perpetuate asphalt. Asphalt's the #1 recycled material on planet Earth. So what we do when we build, when we maintain existing roadways is we'll mill off a certain portion, a certain thickness of the existing asphalt pavement surface. Those millings are then hauled back to the plant, cleaned up and run through a screed, crushed, and then they're actually added in as part of the mix design of an asphalt pavement. FDOT allows up to 40% of any given mix to be included as recycled asphalt pavement in the mix itself. So in a real world scenario, we typically don't pull anything less than or more than 30% wrap. So you've got 70% virgin rock and binder, and then 30% recycled asphalt pavement. So the more you do that, the less natural resources, the less virgin material you're using, the less tax on the environment and the quarry that you're doing. Okay, very rarely will virgin asphalt or 100% virgin material be used. Only if it's specified by an engineer that's wackadoo, or it is a new pavement, new government constructed roadway where they'll come in and they'll start with virgin material. The cost is about 25 to 40% more depending on the mix if you want virgin versus a 30% recycled mix. I prefer to use the recycled mix simply because not only just cost constraints, because I don't like overtaxing the environment, overtaxing the quarry, use of virgin materials. If we did that only, we would run out of aggregate eventually. So what am I going to do when I start laying this stuff? So I got my plant, the plant's waiting for me. I got an order in for, say, 400 tons we're doing today. So the first thing I'm going to do is prep the surface. And this is very important. I'm going to use a milling machine on bigger projects. That's the white machine you see there. This is a big, destructive, badass machine. And all it does is grind through the asphalt at a specified depth. The cool thing about a milling machine is if I've got 4 inches of asphalt, let's say on a roadway, I don't have to take out 4 inches to repave it. I can specify a depth of, say, 1.5 inches, and I can mill out that 1.5 inches and put back 1.5 inches. So I don't have to take out everything that was constructed first. Now, as we talked about at the beginning slides, if I've only got 1 inch or 1.5 inches of asphalt, I'm probably milling down to the base rock anyway. But in areas where I have thicker asphalt, or in areas that have been overlaid, 3 times a parking lot, or roadways have been overlaid, I can take off a specified depth, so I don't have to go full depth. What happens is this machine's got a 4 foot to 6 foot wide steel drum that spins at a very high rate of RPMs, and it has carbide bit teeth on it. And as it moves along, it chews up that surface at the specified depth. And then you can see it comes through that long conveyor neck, and it spits the millings out into the back of a tandem dump truck. The reason we've got that truck there is because we want it to collect as many millings as possible. This is kind of some dirty work. It's very loud, it's very destructive, and it is very dirty if you allow it to be. So there's still millings that are left below that drum that are going to be swept up after the case, but the bulk of them are going back into the truck. That truck gets hauled to the plant and it's dumped, and those millings are then again used in new asphalt. They're recycled and reused in new asphalt material. When to mill and when not to mill is kind of up to the existing pavement condition. You can see I've got full or transition milling. We can talk a little bit more later on what transition milling looks like. But if I've got a roadway that's 24 feet, 2 standard lanes, I'm typically going to mill full width, or the entire width of the roadway at specified depth. Okay. I do that so that I can keep my drainage exactly where it is. I can keep my crown or my invert elevations where they are. We don't want to change any elevations if we don't have to, simply because you can create water ponding problems and issues, and we don't want water on the surface of the asphalt or in the base rock. Okay, water is the root of all evil in pavement design and construction. I'll say that more than once over the course of this presentation, but we want to keep water off the surface as much as possible, and out of the base as much as possible as well. While I'm doing my milling and my removal process, I've got a truck being loaded at the plant, okay, or multiple trucks being loaded to stage at the plant. Okay, I'm going to put a liquid tack coat over the surface. This is a Grandoise example, but usually a good rule of thumb for my liquid tack coat is you shouldn't be able to take a step on the tack surface without getting tack on your shoes or on your boots. All right. This tack coat is kind of my bonding agent between either the milled surface, the base rock, or just a regular non-milled asphalt surface if I'm doing an overlay. All right, this is basically creating a very sticky, very adhesive surface that my new asphalt is going to go down on. If I don't put down tack, I'm going to risk delamination, where you actually have parts of the asphalt that shove up and slip off of the surface because there's nothing holding it to the previous surface that's being overlaid. Think of it like your driver's license. You've taken in and out of your wallet 150,000 times over the years, and the edges start to peel back, and that laminate starts to come off. Same exact principle. Okay, I don't want that asphalt, the new asphalt, to slip free from the surface, so that's why I'm going to use a tack coat. After my tack is applied, I've got my truck that was sent to the plant, and it's going to load into my paver to overlay the surface with a new pavement. Okay, again, I'm using a wear and course mix, a surface mix. An example of that is Super Pave 9.5 or S3. That's basically means that 9.5 millimeters is the largest rock that's in that mix. So I've got 9.5 millimeters and under within that rock matrix. That truck is going to offload into my paver hopper. You can see the kind of the yellow thing in front of the paver there. That hopper will hold about 5 tons of material, and he's moving along with the truck. Okay, what that hopper does is it grabs that 5 tons and it consolidates it into the paver itself to run back through the screed. So it goes down and then it goes through a screed. What the screed's doing is it's saying, I'm going to come out of the back of this machine at a specified thickness. All right, so it's consolidating all of that hot asphalt, and it's pushing it down through the back of the paver, down through the screed. All right, if I want to put an 1.5 inch finished compacted pavement down, I'm going to set my screed at about 1 3/4 inches. Okay, because remember, I still have to compact this, and I still have to compact it when it's hot. The driver there, the guy that's highest up in the seat, that's my operator. All right, so what the operator's job is he's controlling the yield on the project. The faster he goes, the more tons I'm able to put down, the more inconsistent my product's going to be. The slower he goes, maybe the prettier the job's going to be, but then I can get behind schedule and get over budget. Okay, so his job is to kind of keep things moving in the right direction, slow and methodically, without over or underdoing his speed. All right, he's also checking the surface, the control. He's seeing if there's any voids, if we've got to have some asphalt shoveled into the front to correct something as we're coming along. The 2 guys on either side off the back, they're controlling the screed. Those are my screw men. All right, so they're both determining how thick that material is coming out the back of the paver. Why a guy on each side? Well, because roadways aren't consistent, build surfaces aren't consistent, and parking lots certainly aren't consistent. So we can do micro adjustments to the screed to ensure I've got a nice level surface, and we can fix any surface inconsistencies as we're paving. Okay. After it's out of the paver, I'm going to roll and compact it with a vibratory traffic roller. What this guy's going to do is he's going to get me my finished elevation and my fully compacted surface for the asphalt, so cars and trucks can drive on it. Out of the paver, I've only got about 82 to 85 relative compaction, which means that if I put a truck on that without compacting it further, it's going to create ruts. It's going to shove the asphalt. It's going to create tire tracks. It's not ready. Okay, you're not finished once it comes out of the paver. Even though it may look nice and smooth, you don't want to drive on it right there. You've got to put this traffic roller on it. This roller weighs between 4 to 6 tons, very heavy. And we're going to do an industry standard of 2 passes in both directions. 2 with the vibrator on, 2 with the vibrator static. Okay, so my first 2 passes are going to be vibrator on. That's going to give me my most compaction. It's going to consolidate the material and press it down. And then my last 2 passes are going to be with static, without the vibrator on. All right, and that should get me down to about 92% plus in relative compaction, and I'm ready to drive on it. Okay, this all has to happen in about a span of an hour to 2 hours to ensure that I'm compacting that material at a temperature of about 225 F or above. If I don't compact it at that heat, if I let it get a little bit colder, then I risk loose aggregate at the top called raveling. I risk segregation, where a lot of the, you can see some voids in the aggregate themselves when you look closely at the pavement surface. The ideal pavement surface is going to kind of look very, very flat like glass. All right. My next step is I'm going to compact it with a rubber tire roller. That's going to give me the surface consistency that I'm looking for. It's going to fill any of those voids if like some rock popped off the surface during the other rolling procedure. And it's going to give that material its first kind of introduction to what a rubber tire feels like. So we're basically getting it prepared for tire traffic from cars and trucks. All right. So after that point, I'm done and this is ready to drive on. My last step is I'm going to apply the pavement markings per the design professional or local code. Pavement markings are a traffic control measure. These are safety measures. All right. They're telling people when to stop, where to turn, and where to park. All right. So we can't take these for granted, and you certainly want to get them right the first time. All right. Especially on a brand new pavement. So a stop bar, that's what that thing is. It should be accompanied with a stop sign nearby. That's where you're supposed to stop. And everybody in the audience, you're supposed to stop behind this guy. I don't know if you remember from driving school, you're supposed to stop behind this guy. Then you can slowly move out to the intersection and make your turns or make your through movement. All right. So that's why we have the stop bar there. Directional arrows will tell you which way you need to go as far as traffic flow. A little bit of tidbit here. Something that's not necessarily asphalt related, but I think everyone should know. When I've got a double yellow line, that means that I've got traffic moving in two different directions, and it's going to split that. If I've got a single white line, that means I've got a lane division, but I've got traffic moving in the same direction. Okay, so when you see yellow, that means it's splitting a traffic lane that for cars that are moving in opposite directions. When you see white, it means you're separating traffic lanes that move in the same direction. Okay, very simple. A lot of people may not know why we do it that way, but that's why it's done that way. On the right, you can see ADA parking laid out. It's very important to get this stuff laid out right, especially when it's angular parking. All right, you do not want to go out and black out ADA parking after putting down a $500,000 paving project. It's embarrassing. I've had to do it once. I'll never do it again. So when I do striping, it's very, very much set up and measure 3 times, paint once, and get it right the first time. I don't have to tell you guys, but especially with regard to ADA, it is a code enforcement thing, and you need to have the right spacing, the right angle, and the right size for both the parking space and the access aisle to ensure that you're compliant with ADA code. So let's get it right the first time. All right. So I've got my brand new pavement. I've made this investment. Everyone in the community is super, super happy. The projects get done. And now, just like everything else in life, it starts to decay and die on us the second we walk away from it, right? Whether you put a new roof on, or whether you do an HVAC improvement, or whether you do a parking lot, Earth starts to take over, the elements start to win, and we got to know how we're going to maintain this thing. How we're going to maintain this investment, okay? First, we're going to talk about corrosive substances. These are the things that are bad for asphalt surfaces, okay? Gasoline and oil spills. I don't have to tell you that. Go to any AutoZone or Advance Auto or O'Reilly Auto Parts and look at the front parking spots and see what oil stains do to asphalt pavement, okay? Battery acid and chlorine, typically not something that we've run into, but certainly you don't want, chlorine or petrochemicals on the asphalt surface. It will eat it away and decay it. Sun and ultraviolet rays, especially down here in South Florida, it's something that we have to keep an eye on. And so one of the reasons why South Florida does so much seal coating. And oxygen, certainly just the wind and everything. But the most erosive substance on planet Earth is water. That applies across the board, not just asphalt pavements. But if it can create a canyon, which is this grand, it can certainly create erosion and premature wear on the asphalt surface. So I'll say it again, water is the root of all evil in asphalt pavement construction and maintenance. We want to keep water off the pavement surface as much as we can, and we want to keep water out of the base, especially in northern climates, but even down here. You don't want water to get into the base because a base rock is much more erodible than an asphalt surface that's been compacted. Okay, it's just kind of common sense. You want, if something is easier to drain through, then it's more erodible. That's just the way water works. All right. So what are some typical asphalt surface failures that we deal with after we construct and while we're maintaining our asphalt pavements? Certainly damage due to poor surface or subsurface drainage. If I've got area drains or inlets within my parking lot or within my roadway, I want to make sure that water's getting to those. Okay. In this case, you've got kind of a curb that's damming some water, and you can see all the damage around that that grate inlet right there because the water's not getting into the grate. Okay. So you've got a combination of restricted flow, or the drain is sitting higher than the asphalt around it. So as water ponds around there and it gets driven on, the asphalt starts to fail. If you've got an area in your community or in a parking lot that holds standing water a lot, go look at it when it's dry and you'll see fatigue cracks starting to form. You'll see asphalt failures. You'll see depressions and rutting in those areas simply because you're weakening the surface by leaving that water on the surface. Fatigue cracking due to repeated heavy traffic loads. Typically, that's what it's caused by. This is also called alligator cracking because of the shape that it makes. It looks like kind of the back of a gator. This is a structural failure, and this isn't a surface that can just be milled partial depth and overlaid. Again, asphalt's only as strong as the material that you're putting it on top of. So if you've got a nice sturdy foundation, a solid base, or a nice structurally performing asphalt, you can cap that with more asphalt and you'll be just fine. If you've got a structurally failed base, such as a fatigue crack or a high severity failures like this, and you just put asphalt over the top of it or even mill portions of it, you're going to see those failures reflected through. Okay. It's very important that we address this from a full depth or structural perspective before we go in and make any new overlays or improvements. Oxidation from the sun and ultraviolet rays. This is a big one. And it really certainly applies down here. But when you have a surface asphalt pavement, it starts to oxidize day one from the sun. Okay, so you have a bituminous material. Remember that binder. It's an oil-based material, and it will start to oxidize. Just like the 2002 candy red Honda Civic that you bought brand new and drove it off the lot. If you didn't wax it, if you didn't maintain that paint, which is a bituminous paint, okay, it's an oil-based paint. If you don't maintain it, it starts to turn pink. All right. That's not just the Lord's work. Well, it is, but it's because the sun is shining on it. That sun creates oxidation of that paint material, and that oxidation causes that bitumen to evaporate or oxidize, and you're left with what the base layer is. The base of the car is going to be the metal that the car is made out of. So it's going to be a tempered, it's not going to be as red anymore. What was the color of those stockpiles in one of our first slides at the asphalt plant, right? It was gray. So when asphalt oxidizes, you're removing that black liquid binder, you're removing that oil, that bitumen. As it oxidizes, you're left with exposing that rock, which is gray, which is why all asphalt pavements over time, as they oxidize, turn different shades of gray. The longer you wait to touch it or to seal coat it or do anything to protect that surface bitumen, the grayer or whiter it gets because you're getting down to just rock. All right. If we leave it untouched, we get what's called raveling. Okay. So if you can kind of stay with me here, I've got a nice black solid asphalt surface. I leave it alone and I let the sun do its damage. 1-2 years in, I'm doing great. No problems. Nice and tight matrix. I don't have any loose rocks at the top. 5 years in, I haven't touched it. I'm starting to get some rock that's popping loose, some aggregate that's popping loose from the surface because I'm losing that binding surface agent. That binder is holding all of my rock together, remember. So if I'm losing that off the surface, I don't have anything to hold the rock anymore. All right. And so it starts to pop loose and it becomes kind of gravelly. If you go out to a parking lot or a roadway and you can kick your heel on the ground and dig up loose rock, that's called raveling, and that's bad. That's really not a failure that we want to have happened to our pavement, because what happens again when I don't have nice tight matrix at the top, when I have loose rock at the top, now I'm allowing water to infiltrate and penetrate through that surface, and then water gets into the base rock, and I start to have more structural type failures because I've weakened the entire structure of the pavement there. So very important. It starts at the surface, but you let the sun to oxidize, you get loose rock, you get a more permeable or pervious asphalt surface that allows rock to drain through it. Then I've got problems upon problems from that. Oil, gasoline, petrochemical spills. This is an example of oil stains that have been left unaddressed. Those potholes there are not caused by standing water or caused by repeated heavy traffic loads or under design of the pavement. That's simply something that has eroded over time due to oil sitting on top of it and softening the asphalt. All right. Asphalt hates motor oil. It is corrosive and it will absolutely fail the asphalt pavement there. Okay. Here's some other examples. Potholes. Everybody knows what a pothole is. Usually potholes are caused from fatigue cracks. All right. So I've got a fatigue crack. I've got repeated traffic loads over a structurally failed section. Usually in roadways, it's in the tire path. Shocking, I know. You very rarely see potholes at the center of the road or at the edges of the road. You see them in the wheel paths. But usually those are from fatigue cracks that the alligator crack, or they get so close together that they all pop loose at once. And now I have an open hole that has to be addressed. Sinkholes, that slide in the middle there, isn't a pothole at all. Okay. And a lot of times there's diagnosed as potholes, and you go out and you saw cut it and you patch it and it sinks again. And you call me and you say, Chad, you just did this patch a month ago and it's already failing. That's an indication of something that's much more severe going on below the surface. All right. Sinkholes in asphalt pavements are usually caused from a drain pipe that has a breach underneath the surface. All right. 9 times out of 10. I would say even 99 times out of 100. Sometimes you can get a sinkhole from offsite runoff coming in and washing away the base, like on the edge of the pavement, and you kind of see it start to form. But usually a sinkhole is formed because you have some water that's leaking out from under the pavement surface, as deep as the pipe is, and it's eroding the subgrade, it's eroding the base, and all of a sudden that erosion makes its way all the way to the top. All right. So sinkholes can sometimes form, and you'll see it'll look like a pinhole at the top, but underneath it, you've got maybe a 6 foot deep by 30 square foot cavern that is an empty void there. And so since asphalt's only as good as the material underlaying it, if there's nothing underlaying it, you're going to have a massive failure. You're going to have a sinkhole. Okay. Delaminating overlays. This is again an example of coming in and doing something that's not sound. That's kind of a ridiculous Band-Aid. If you invest in an overlay and you don't do something to address the structural failure of the material that you're putting on, it's going to fail. And it's not only going to reflect, but a lot of times it's going to delaminate like this because it just doesn't have that bond there. Or again, when you have a lack of tack coat or no tack coat, you can get delamination from your new pavement surface. And then high severity alligator cracking, loading, these are subgrade failures. If you see native soil or brown spots coming up through the surface of the asphalt, that means that you have a failed surface, you have a contaminated base, and now you've got to do something much more heavy and costly to that pavement than just a mill and overlay. Okay, so when it gets to this position down in the bottom left there, we've got to deal with that much more accordingly. When I have patching, and I have a pothole or some fatigue cracks, I'm going to do patching. What I'm going to do is I'm going to saw cut, I'm going to take that asphalt up, and I'm going to replace it. When I do saw cut patching, keep in mind, I've got to take asphalt out full depth to the base. So if it's 3 inches of asphalt, I got to take out 3 inches, I got to put back 3 inches. The slide on the left there is one of my pet peeves. It drives me crazy when a contractor goes out and they see a hole and they patch just around the hole, leaving the rest of that fatigue crack or that failure for a future failure. And what inevitably happens is I'm going to create a new pothole adjacent to that patch because I didn't address the whole thing. So I didn't take all of the weak or failed asphalt out. A good rule of thumb here is I tell my guys at a minimum of 1 foot outside of the failure. And you want to do patches that are kind of uniform, that are rectangular, that are square. You don't want to do zigzag formations or checkerboards or Tetris pieces. You want these things to encompass. You're not saving a whole heck of a lot of money by not encompassing the area in a nice square. Also, small patches fail faster. So I want to get something that's both encompassing the failure as a whole, not just the hole that's there, okay, but encompassing the fatigue crack as a whole, the whole perimeter of it. And I want to make sure it's large enough that it's not going to kind of be lost in the shuffle or be damaged in the future. So our transition mill and overlay, something that we do pretty standard is if I've got a nice solid surface and it's structurally performing, and say it's 15 years old, but it doesn't have a whole lot of failures there. It's been patched every once in a while. They've done a good job seal coating this property. I can do what's called a transition mill and overlay, okay? Where I can come in and only mill at my tie-in. So I'm gonna mill at my landings for my ADA ramps. I'm gonna mill at the transition between asphalt pavement that I am overlaying and asphalt pavement that I'm not touching, say an intersection or the border of another property. I'm going to mill at all of my inlets, so all of my drainage inlets. I'm not going to just pave up to the edge and leave an inch lip. That's bush league gypsy stuff. You don't do that. So I've got to remove some of the asphalt. But you can see on the right there, I can cap an existing pavement surface as long as it's structurally sound with asphalt. And I'm not only saving money because I don't have this, other phase that I'm going through to mill and remove a portion of it. But I'm also increasing the strength of that material. Very rarely in the construction world can we go into an existing situation and increase the overall strength and durability of a material. But when we do overlay the surface, we've got, say, 2.5 inches of asphalt. If I put another inch of asphalt on top of that, I've got a new structural number entirely, and I've actually strengthened the overall pavement there. We can only do this a couple times though, because then you start getting into drainage concerns, grading concerns. If I raise the elevation too much, and you'll see this, I guarantee it, now my drain inlets are sitting too low because now I put 3 inches on top of this thing. And yeah, even if I milled around and I tied into it, now my drainage inlet is 3 inches lower than the surface around it. And you can have, bottom out, you can have, situations where you have a localized depression there. So you want to avoid that. And then complete full width mill and overlays. So this is again where I brought that milling machine out. I milled the entire surface, and then I overlaid that milled surface. And sinkhole repairs. All right. So here's a sinkhole. This is a good example that I want you guys to kind of understand. When you've got a sinkhole or you think you've got a sinkhole, it needs to be addressed properly. First of all, you need to get an asphalt paving contractor that knows what the heck they're looking at. All right. So they need to be able to ID the rudimentary difference between a pothole or something much worse like a sinkhole. Usually you can see there's a void underneath it. So that's going to be my number one tip is there's no base rock, there's a void, something's wrong. In this case, it didn't take a scientific rocket to figure out that I've got a grade inlet, curb inlet combo that's a couple feet away. So I know that I've got something going on here, and it's either got to do with the pipe that's connecting that inlet to another inlet, or it's got to do with the box itself. Like water is getting out of the inlet box itself or the manhole itself and allowing it to seep into the base around it. In this case, I don't know if you can see from the other side of the fence here, but you've got a inlet on the other side. So my pipe is just running in this way. It would be very rare for this sinkhole to form if I had a pipe breach connecting those two inlets. So what I figured is I had a shoddy installation of that grade inlet. All right. So I'm not going to be able to determine that until I dig the area out. Okay. So we call this excavate and investigate. We're going to find out where the heck that water is getting out of, and we're going to make sure that we do the proper repair. Well, in this case, I have this cap here. Here's your manhole, and here's your cap that had the inlet affixed to it. And you can see you have a void between the two. This should have been filled with hydraulic cement or some sort of flexible connection material that didn't allow that. Instead, what they did was, no one's ever going to look at this. Again, I don't have to worry about it. It's off in this corner of this parking lot. It's not such a big deal. It is a big deal. And in times of heavy rainfall, and I don't have to tell you, in South Florida, we can get pretty intense rainstorms. This is actually over in Doral. Water gets above that threshold there, moves basically from the bottom of the drain all the way through the box, and it fills up there, and then it was allowed to seep out of this portion. And you can see how much void was created because of that. You know, you've got the pavement surface here. My guy's knee deep in this hole, and you've got a significant void here. All right. So the first thing I'm going to do is I'm going to fill that void between the concrete cap and the circular manhole box. And then I'm going to backfill this thing really well with lime rock base before I go back and patch it. Okay. So a lot of times it's more than meets the eye, and you have to kind of dig in and see what's going on. All right. In this case, if that sinkhole would have been allowed to keep forming without addressing it, this void here that goes towards a public street would have collapsed the curb, and then eventually would have collapsed the earth around here, and leading to much more problems with the right-of-way repairs, right-of-way permits, etc. You don't want to get that far. All right. Full depth reclamation and mix and mill. So if I've got this condition here, where I've got this high severity alligator cracking, and I can see the subgrade pumping through the surface, I don't get to just play nice and mill and overlay anymore. All right. So what I've got to do is, I've got failed asphalt, I've got contaminated base. I'm really at dire straits here. All right. I can't do a mill and overlay. It's going to just fail immediately. In this case, for this particular example, you had about a 1/4 inch to a 1/2 inch of asphalt that was apparently laid on either native subgrade or a very, very small amount of base rock. This was certainly not a good installation job from Jump Street. When you have poor new construction, you have poor maintenance. And if you don't do the things that you need to do to get it back to what it should have been, you're going to perpetuate this problem years and years and years down the road. It's just kicking the can. So a good engineer is a little bit lazy. All right. That's Noel's rule, one of my surveying professors from back in the day, the beginning of the 2000s, said a good engineer is a little bit lazy. All right. They're going to find the easiest fix. Usually the engineer's fix is, all right, so I've got this type of failure. I'm going to go to the book. What's the book say to do? And the book says I need to do full depth reconstruction. Okay. So when I do a reconstruction, that means I'm taking all the asphalt out. I'm taking any base out, especially if it's contaminated, and I'm taking maybe into the subgrade out, and I'm going to stabilize that subgrade. I'm going to bring in 6 to 8 inches of new base rock, and I'm going to put down 2 inches of asphalt. All right. Because that's what the book says to do. Well, sometimes those lazy engineers are also pretty smart about it. And they're like, listen, we can be lazy and intelligent at the same time. So what if we, instead of hauling all this material off, which by the way, when I take all that asphalt and all that subgrade out to 10 inches, say, all that's got to go to a landfill. It's contaminated material. I can't just find a place to dump that. The plant's not going to take it. They got no use for it. It's not aggregate, it's soil. So it's usually going to go to a landfill, and that's very wasteful. Then I'm bringing in brand new base, like I'm building a brand new parking lot. Okay. And so I've got a lot of new material that I'm bringing in. When I do that, I'm both taxing the environment and I'm taxing my customer, right? I'm spending a lot more money than needs to be. So back in the 80s, a group of geotechnical engineers said, hey, we've got some decent material on site here. What if we were to kind of recycle it in place and create a new base material so that then we can just bring in new asphalt, pave it, and we've got a brand new parking lot with a stable base that's going to be, service life of 15 years again, without all the headache of the removal, haul off, and import of new material. So that's exactly what they did. And they created a process called full depth reclamation, where I reclaim what's there and I leave it in sight. So this is kind of like using a tiller If I have any gardeners out there, so you're going to use my tiller. I'm going to till the material, the spent nasty soil at the top that doesn't have any nutrients left. I'm going to bring all the nutrient dense soil from below the surface up to the surface, and then I'm going to be able to plant a garden that's going to be productive for me. I'm going to have a bountiful harvest instead of trying to reuse the old surface soil over and over and over again and get less and less crop out of it. All right. So I'm going to till or reclaim this material, and I'm going to go a specified depth, usually about 12 inches. So I'm going to blend all that asphalt, any of the base rock that's there, contaminated or not, and some of the native soil in place to create a new base material. I'm going to maybe treat it with lime, fly ash, or cement on the top, depending on my soil conditions. And I'm doing that so that I'm both stabilizing that new subgrade and I'm making it nice and hard. Okay, I'm gonna make it a nice solid material, especially if I've got a lot of earthen material here and not much base rock. So I'm tilling it, and that's the machine over here in the top right. And then I'm just gonna roll it. I'm gonna roll it with one of those heavy rollers that we saw earlier, and I'm gonna grade it. So I'm gonna fine grade it like I would grade any roadway, and that's kind of reestablishing the grades that are there. Reestablishing the elevations that are there. Once I've created that new surface, I'm fine grading it, recompacting it again, and then I'm paving over the top of it. When I pave over the top of that, I've got a brand new pavement surface with 90% of the material reused in place, and only the asphalt brought in separate. So I've got a little bit of spoil. Obviously, when I do some regrading or I fluff it up, I've got a little bit of spoil that I'm going to be taking off. But I've really got a lot of solid foundation, a solid base to use there without taxing the environment, without bringing in a ton of extra material. Just kind of ballpark figures. Full depth reclamation is going to run about $8 to $10 a square foot, whereas a full depth reconstruction can run 30 plus up. Okay, completely different ballgame. Temporary asphalt repairs, you can do these. These actually will last sometimes in South Florida longer than we want as paving contractors. You can use cold patch. You can get it at your local hardware store, and you can go out and you can compact it. I used to carry a cold patch in the back of my Maxima, and when I had a customer that was desperate, or they needed to get 3 bids, or they couldn't just go out and tell me to go get permanent repairs, I would go out and I would evaluate the parking lot, and I would throw cold patch in their open holes, especially libelous ones, or ones that are out in the intersection, places where potholes tend to form. And I would put the cold patch in and roll it with the Maxima, and it's lasted. I've got some that are still there. Infrared repairs, we typically don't use down here in South Florida because we don't have a whole lot of asphalt to borrow from. But what this involves is I'm heating the material that's in place, I'm making it malleable again, and then I'm raking it into a void or into a pothole and then recompacting it. They use these a lot in the north when the plants are closed for extended periods of time, so that they can kind of fill holes that way. All right, preventative maintenance seal coating. The moment we've all been waiting for, right? I've got my brand new pavement. I spent, say, hundreds of thousands of dollars on it. I budgeted for it. Now I need to protect it. I've got to maintain this stuff, guys. We don't want to get into the habit of constantly going out and patching potholes, patching areas, patching root damage, things like that. I can protect this in other ways. All right. So the main thing that asphalt's going to do is it's going to protect from oxidation and reduce the erosive effects of water. Remember that gray, nasty parking lot that we saw that's never been seal coated? If I went and seal coated that thing, I'm doing it purely for beautification purposes. There's no binder left on the surface. But I've got my brand new overlaid parking lot or overlaid roadways in my HOA. I want that asphalt to be protected. And most importantly, I want that layer of binder at the very surface to be protected so that it doesn't start to lose rock, so that it doesn't start to lose that tightened surface compaction. All right. So I'm going to seal coat. That's how I'm going to protect that. All right. Seal coat does not add strength. It does not add longevity or wearability. What it does add is the ability to keep that top layer of binder in place without oxidizing over time. That leads to longer structural performance. That leads to less rock on the top, and that leads to less potential for water to impact or infiltrate through the pavement surface and into the base. It also protects asphalt from deterioration from fuel, oil, and petrochemical spills, mostly oil. If I use a coal tar sealer and I have that oil stains like you saw in the oil slide, it's no longer going to hurt the asphalt. It'll sit on top of it for sure, and it'll be there. It'll look nasty, but what it won't do is penetrate that asphalt and pit it and create that pothole scenario that we saw. Extends the life of the asphalt pavement, and it does beautify the property. Absolutely. You know, when you put down a brand new seal coat, it not only makes it black again, but guess what happens when you restripe? All the lines are easily visible. If I go out and I restripe an oxidized parking lot, that paint's going to last half as long, and I'm not going to be able to see it. It's not going to be as vibrant because it's going to soak into the asphalt. It's going to wear faster, and it's not going to be as vibrant. This is a degradation curve. That's basically a nerdy way to say the way things die over time. Your blue line is my condition of asphalt left unprotected. Okay, it's my do nothing scenario. So I've got a 15-year design life of this asphalt. You can see that over the first couple of years, I'm going to be okay. Then I've got a much more drastic slope on that curve as it gets to a poor performance quality. And my green line is a typical 3 years seal coating application where I'm going through, and now I'm kind of not totally bringing it back to 100% quality, but I'm extending the life of that asphalt pavement because I'm keeping that binder nice and tight at the top of the pavement. All right, I'm keeping that rock nice and tight and not allowing it to ravel. Okay, so you can see when I get to my 15-year period, now I'm at a level of service of, say, a high C or even a B, and I've extended the life of that pavement for 10 more years maybe until I've got to overlay. I've also spent less in maintenance costs doing pothole repairs. I'm striping every time I'm seal coating. So you're striping regardless, right? You're striping whether you seal coat or don't seal coat. So I'm saving money, and I'm doing the right thing by my customers, by the people that are utilizing this, whether it's a shopping center or an HOA. I'm really delaying the cost of a capital project while spending less on a yearly basis in just general maintenance. These are our examples of coal tar emulsions. We Polypro and Sta-Co JC7. Polypro is a highly formulated product. It's got a lot of polymers in it. It's very durable. It goes down very, very black, and it lasts there for a long time. And then Sta-Co, it's kind of the standard federal spec sealer that we use. There are asphalt emulsions. Okay, some states and municipalities require you to use an asphalt or instead of a coal tar emulsion. Real quick, does everybody know what an emulsion is? Didn't think so. So you know the old saying, asphalt and water don't blend. Well, they do, and it's an emulsion. So we mix our sealer either here in the yard or pre-mixed at the plant with cutbacks of water. Okay, that's what the emulsion is. If you use shampoo in your hair this morning, that was an emulsion. If you are going to eat a vinaigrette on your salad later today, I hope you're at least eating a couple salads a week. That is an emulsion. All right. I wouldn't encourage you to put a coal tar emulsion down on a salad, but these are the same from a chemical reaction perspective. This is the same type stuff. Okay. So in summary, asphalt pavements are built over crushed aggregate base materials and consist of rock and aggregate binder. Asphalt's only as good as the material that you're putting it on top of. If I've got a nice structurally sound foundation, whether it's a base rock or whether it's a nice built, maintained asphalt surface, I can put new layers of asphalt over the top of it, and I can expect it to perform accordingly. If I have structural failures, or if I have a contaminated base, or not enough base, or no base at all, expect immediate failure. They're damaged by petroleum distillates, petrochemicals, oxidation, and water, primarily. They can be easily repaired by removing and replacing damaged sections or by overlaying, depending on what our existing conditions are. And asphalt can and should be seal coated as a preventative maintenance measure to protect, beautify, and extend the life of the pavement surfaces. Spend your money the right way and plan ahead, and then you can make everyone in your world happy. All right. We don't want upset board members, and we don't want upset customers when we're constantly playing the reactive game. That's what I got, and I will stop a share here. It looks like we had several questions come through.
There was one they didn't place it into the Q&A, but in the chat area. So folks, if you have any questions for Chad or anybody from the Community Safety Resource Group, please put it into the Q&A module, not the chat module. And the question came from Deanna is how long does this coating typically last and how often should this be done? But I don't know at what point she asked it when you were talking. That's the problem.
Seal coat most likely.
Okay.
And so seal coat is kind of going to be dependent on how much traffic you've got, what our wearing conditions are. I would typically encourage a 2 to 3 year interval on average. You really don't want to seal coat every year because then you don't have enough sealer wearing off, oddly enough, and then it kind of builds up on top of itself. It's super thick and you can get friction loss. Okay, so you get a lot of sealer kind of stacked on top of itself, and you can actually have a negative thing where it becomes really slippery and you don't have the friction or the ability, the traction for vehicles. So usually I encourage people to look at a 2 to 3 year interval where we're going to be seal coating. All right. Anything more than that, and in my wheel paths and heavy traffic areas, you're going to see the sealer worn almost down to the original pavement surface in about 18 months, or even less in some cases. Where there's a lot of water directed in low-lying areas or in my inverts in the middle of the street where there's a lot of water running, that water will wear the sealer as well. So I would say, if you can budget for every 2 years, stretch it into 2.5 or 3 years, you're probably going to be okay.
Chad, there was a question as far as what counties does your firm serve?
Everywhere in Florida, even the Panhandle, reluctantly.
Terrific.
We have our offices, our primary offices are in Miami, Orlando, and Fort Myers, with Tampa and Riviera Beach as kind of sales offices.
Hey, Chad, I have a question. When I was managing on the field, even if I was happy with a current vendor that I had, I would hire another vendor that does the same thing to make sure we're not getting screwed as a consultant, that kind of a thing. So let's say somebody is happy with their service provider for what you do. Can they still bring you on as a consultant to make sure that the right things are being done? Do you also provide those kinds of services?
I'll do whatever. I like for people to be educated, and I like for people to get what they pay for. I've done this for a long time. I've seen contractors that are spectacular, that stand by their word, that know what they're doing, and I've seen absolutely abysmal work.
Right.
And so, yeah, I would encourage anyone to go out, get an opinion of it. I mean, I'm a civil engineer by trade. I also do ADA inspections. I do, I've acted as an independent expert on projects that, asphalt pavements have prematurely failed.
Yeah.
And so, it's good to have an outside source. You could either look at third-party engineers like a geotechnical engineer or someone else that's an expert in the industry for more of an idea of the best things to do with that regard.
There was another question from Harry. This is more on a technical side. I was told that the steel wheel roller should be 10 tons of weight to be most effective.
Yeah, so there are applications where you're going to bring in that big roller. That's going to be a static roller. The vibratory rollers max out at 6 tons. So when you see those big 10-ton static rollers, those are going to be used in highway applications typically, where I'm putting down 2 or more inches of asphalt. So I've got to make sure that I get very, very high level of compaction. If I'm going with a lift thickness over 2 inches, I want to make sure I'm getting solid compaction in that, and that's when I'm going to bring in that heavier static roller. But for applications under 2 inches, using the vibratory 2-pass static 2-pass for a 4 to 6 ton roller is going to get you ample compaction in that application.
Also, Chad, years ago I heard about the slurry system. I know they use that on a lot of highways and all, and I think that you have to have a lot of width. It's not good for very, small streets and all, but is that something that's done down here in Florida?
Not typically. We use a seal coat called a rejuvenator. That's a little bit different from a standard seal coat that actually penetrates the asphalt surface. It's meant to rejuvenate the binder that's under the surface that's been oxidized. And we've seen promising results with that in both wearing and longevity increase. A slurry is approved as FDOT. It kind of takes a special machine. Usually, if you're a slurry contractor, you don't pave, and vice versa. Slurries were used by highway departments for county roads, less traveled roads, areas where it's tough to get asphalt over to, or communities which can't afford a brand new mill and pave or resurfacing of the road. And so they would bring in a slurry seal to kind of add some durability, a measure of strength increase, not much, but kind of as a in-between maintenance technique. But slurries basically are a combination of an emulsion that we would use for a seal coat and some kind of aggregate, whether it's decomposed granite or a small crushed rock. But yeah, we don't put down slurries. I've seen many different types put down. They usually go down about a half an inch, quarter inch to a half an inch thick. And so it's kind of I would look at it as an in-between from a seal coat to an asphalt paving.
Right. Then there was a question also about if they end up getting an oil or gas spill on new asphalt, is there any quick remedy or what they should be doing?
I mean, kitty litter and hope that it doesn't last for long. Usually, like if you've seen in NASCAR when they wreck and they have a gas spill or they have an oil spill, they contain it with kitty litter because it's going to absorb what's on the surface. So I get that on there as fast as possible. And then, if it's really damaged and it's brand new asphalt, I would consider saw cutting and removing it full depth. Same with something like if a car catches fire, you can't just seal coat over the top of it. You're going to have, more detriment, more potential for structural failures in those areas, especially with a new pavement, because asphalt's tricky, man. In the first, say, 6 months, I don't want to put anything over the top of it. I want it to be able to break, which is kind of the transition between all of that liquid bitumen having a chance to settle in, be exposed to the environment, and then be part of the hard drivable wearing surface. And I see this great question here by Hanan. The asphalt overlay was completed last Friday, and the contractor suggested to seal coat in 9 months to a year. That's as soon as I would do it, is 9 months. You're not really risking anything extending it into the second year. As far as surface consistency, aggregate loss, oxidation. But yeah, you need to weigh. You got to give this chance. Basically, think of it. You needed to give it a chance to breathe, and have traffic exposed to it. Ensure there aren't going to be any failures from the new construction, and then you want to start seal coating. But yeah, after a year, plus or minus, you're good to go to put a seal coat over the top.
All right, terrific. Let me just see if there's any more.
And yeah, Mount Dora, yes. Deanna.
Then there was another question. Our contractor completed our contract with 1 inch. Overestimated, suggested 1.5 inches. I'm not really sure.
Yeah, okay. So Hanan, yeah, good questions by Mr. Ibrahim here. So you can't go less than an inch. You just can't go less than an inch. An inch and a half, if I'm milling full width, I will specify an inch and a half. And simply because if I'm milling an inch and a half, I know I'm going to hit at least some base rock on 90% of jobs that I go into. When you mill and pave an inch, there's some risk, one, for using a whole lot more asphalt, because if I mill an inch and I expose base, just like anything, if you ever try to put landscape rock into a garden bed and you're like, golly, this first 3 wheelbarrows full just got eaten alive by this. Same with asphalt over base rock. It's not, if I've got just a solid asphalt surface and I'm paving over the top of that asphalt surface and on an inch, 100%, no problem. I'm good to go. The other time I would specify an inch and a half, and without doing full width milling, is if I know that there's less than an inch there currently, even if it is performing kind of adequately, you're rolling the dice. And so when you do an overlay project, there's really two things at play here. There's the budget. So an inch and a half is going to be more expensive than an inch. Milling full width is going to be more expensive than just paving, but there's also the people budget, right? There's your road's going to be shut down. You got to park over here for 3 days. You got after 3 days, fish stinks type scenarios. You got to keep all of that, in consideration. So if I go with a less thick product, am I going to have to be doing this paving job, 10 years down the road instead of 15 years down the road? But I mean, inch minimum. If I'm milling, I want to put an inch and a half back.
Okay, great. I think that's really all our questions right now. I want to thank you. I mean, it's been very informative. It's really a subject that we all need every so often, and we don't know anything about it.
Mm-hmm.
So we really appreciate that. If there's anyone in the audience that has any questions for elevator, for landscaping, for insurance, we can entertain it. We're up against the clock, but we can at least give you some brief information, or at least suggest calling directly to some of our experts that's online currently. I'll just give that a couple of seconds if anybody has anything.
Chad, Denise is asking what the acronym stands for. DMI, is it Driveway Maintenance Inc.?
Denise is dead on. Yeah, I came here. We were Driveway Maintenance Inc. Prior to expanding most of South Florida, we were All Day Driveway Maintenance Inc. So then the reason for our recent name change was kind of twofold. One, people would just standardly call us DMI anyway as a way to shorten it. Sorry, I got a train coming by. Two, because we don't do private or public driveways, so driveway maintenance, understanding when we used to say driveway back, I guess before I was even involved in this, it was kind of roadway, driveway was interchangeable. But we would get a hundreds and hundreds of calls for personal driveways to be reconstructed or redone. And we just don't do we don't do private driveways. So it was just a way for people to understand kind of more what the company does, high level commercial work and HOA type work, not private work. So that's why we made the change. But yes, we've been Driveway Maintenance Inc. since I got here, and operating under Driveway Maintenance Inc. since 1971.
Terrific. Okay. So
Nobody can stump me.
Speaking of stumps, can I jump in here for a second?
Sure.
Chad, I'm sure that some of these associations have experienced the blacktop being pushed up because of roots from oak trees or ficus trees or so on. That should be done in conjunction with your service prior to seal coating and your driveway and so on.
Yeah. So, but when I know this, we're over time, but just a little bit. When I came out of Arkansas and Chicago and understanding, pavements and why they fail and stuff, root was like the number 8 cause down the line. But you get to South Florida, man, and it's 90% of my patching business all of a sudden was root damage and root control, right? Because you've got lime rock, so the roots don't penetrate down into the soil. They kind of track along the top, and you've got a lot of different species that don't have deep root beds because of that. So when you do a seal coat project, patching is going to come as part of that. Whether you've got 2 potholes, or you got a bunch of root damage in your parking spaces. So what we do when we come in and we do root patching is we will prune the root ahead of time. You don't want people in there milling up the root, milling it down. That's only going to reflect over in the future. So we're going to prune the root. We're going to remove the root full depth, that surface root. Okay. When you look at the canopy of a tree, that root system goes out the same width as the highest expansion of that canopy. So if I look at an oak tree and it's 15 feet out from the trunk, guess where that root is? it's 15 feet on the surface. All right. It's largest towards the base of the trunk, but it's, you know, it's the same width as the canopy of the tree itself. When I prune that root, I'm taking that whole bad boy out. Okay. And I'm making sure I'm not going to damage these giant trees. We have arborists involved in some of these municipalities where we got to do it. Here's the deal. As long as you're making a downward cut, a clean saw cut of that root, it's not right up against the trunk, but it's at the edge of pavement. You take that root out, you compact that base or rake in that base so you don't have the void that the root removal created, and then you put the asphalt patch in. Now you're going to be okay. A couple things to create root intrusion in the future. Use a curb with a foundation, so a D curb or modified D curb, where I'm not just on the surface of the pavement itself, but my curb is 6 or 12 inches deep and 6 inches exposed. That can really help the root to guide it along the back of that curb instead of up under the pavement.
You wonder why Charles asked that question, even though he's a landscaper. It was a good segue. Good segue, Charles.
If anybody needs their trees trimmed or roots pruned, give us a call.
All right.
Yes.
There is another question right now off the topic for elevators. I know we're jumping around a little, but Beverly needs a referral for elevators, and the only one that I suggest is Andrew. Andrew, I think you're muted right now.
I'm here. I'm good.
Good. Beverly, the information for the elevator company.
I just sent it to her in the chat.
Oh, good. Perfect. Very good. All right, I guess that's basically it, unless there's any other questions for any of the other panelists from our audience. And again, even after that, if you go on to the COG website, that's CARG4help, HELP.org, you'll have all the contact information there. And feel free to give us a call. Like I say, there's no cost or obligation just to talk, especially now. You know, budget's coming up, you know, I'm constantly asked for different providers. If anybody in the audience has anything on, even on budgets, just in general, obviously they can reach out to me, and I can always direct them to other COG professionals here. So with that said, I know everybody wants to grab lunch. Chad, I want to thank you and DMI for sponsoring this. It was very informative.
Great presentation,
Absolutely.
Chad.
And
Everyone out there, if you have an organization you're a part of, like within your company, and you want me to come do a quick lunch and learn, we do concrete, we do asphalt, we do hurricane preparedness, with regard to, you know, parking lots and the things to look for, and I do the ADA accessibility code CEU presentation as well. So just get with Maggie and we can set that up individually at your individual companies as well.
perfect. And Andrew, in the chat, you have Beverly's contact information to get a hold of her.
Okay.
All righty,
I see it.
terrific. All right, once again, thanks everybody for joining us. Next month, we will have, in the next few months, we have a whole bunch of other webinars set up, and we'll be sending that information out to you. So again, thanks again, and be safe. And thank you to the panelists.